And this is Mayank.
And we're here to talk about a project Lextor.
So Lextor is basically a connected platform where robots come together, share their data in order to achieve the sustainable development goals set by the United Nations.
So why did we come up with this project? We're all facing several issues.
Like the traffic, 16 people die every hour.
Energy is also a major concern as 20% of the population still doesn't have access to electricity.
And then there is the threat to marine and aquatic life. 40% of ocean is threatened due to human activity.
So in order to tackle all the situations, the United Nations came up with a set of 17 sustainable development goals,
Which you can see above. So Lextor is basically going to use robots in order to help humans achieve their sustainable development goals.
So robots are not the future big trend, but the now big trend.
What we are trying to do is use an artificial intelligence in order to control all these robots. Because humans cannot always be there in order to supervise on everything. So artificial intelligence is going to monitor these robots.
So what exactly is Lextor? In simpler terms, Lextor is nothing but a system where robots talk. And for this purpose, we will create three categories of robots. The wheel robots, which will work on land, the drones, which will work in the air, and the aqua robots, which are going to work in water.
Three things that you should know about Lextor is that it's designed, it's working, and the services that we are going to provide.
Talking about the design, our design is inspired from nature. Like the bees are also creating a swarm of robots in all three domains.
We are also going to incorporate artificial neural network, which is going to replicate the function of a human brain.
The robots will be working on the principle of division of labor, just like the bees. So we'll be having a queen robot commanding its worker robots.
So the robots take in the input from different sensors that we place on them. These things are then processed in Raspberry Pi and the specific file of each sensor gets saved. Then these things are sent to Azure where different algorithms try to analyze the data, and after which the analyzed data is sent back again to the Raspberry Pi, after which these outputs are worked upon by the robot.
So I will be using SSH to log in into our Raspberry Pi, which has an ultrasonic sensor connected just for this demo. So here I have a demo folder with two files, a FTP and an ultrasonic file, both written in Python. And so here let us move into the demo directory. So here what I have is an ultrasonic Python file which will take the data from ultrasonic sensor, convert and save it into a text file. What the FTP library will do is upload this data to Azure, and what I actually use in controlling this is the Lextor console, which I will be using just to control the ultrasonic sensor. So here is our demo. Let me run the ultrasonic Python file. So here it is running, and the command that is currently executed is stop. So what it does is compare a text file which can be seen here, which is ultrasonic status.txt, that the command is stop. So what is it that it accesses this file, downloads it, compares the text and executes accordingly. So what if I do start? So as you can see, the ultrasonic sensor is running and the distance is being measured, and the same distance is being saved into a text file which is known as sonicread.txt, which if I stop the sensor, so here it has stopped. So let me use Ctrl C and see there's a sonicread.txt which was not here before, as you can see here. So looking into this sonic read file is we can see that it is 25.52, which is exactly the last distance measured by the sensor. And after using the FTP library, I uploaded the same data to Azure. So currently the data has been successfully uploaded. So if I check the data for sonic read the text, it will hopefully show me 25.52. Yes, it shows me the same thing, and here on console also it outputs the same thing.